Hi, and today we're going to be starting our first podcast on the unit of ecology. And our agenda for today's podcast is we're going to
Number one, we're going to define ecology, and the second one is the flow of matter and energy in the ecosystem.
I just got that.
Okay.
And this part too. Okay, so here we're looking at a picture that I took in the Grand Tetons. And what are some things we could observe here?
Well, if you look over here in this section,
Okay.
look in this section over here, you notice it's nice and green over here.
And well, what plants are those there? Those trees.
Those are trees, right? And if you look, below here, what do you notice? Does it look as green right here?
Yeah, and I see like right over here. I see like some bare trees, no leaves, and just like gigantic logs sticking up.
Right. So it looks slightly different if you look at the color. So some are like grayish, brownish, and then this is very, very green. So you'll notice the contrast right there.
Right. And also I see here there are no trees at all. Here there are no trees, and we have a lake. And one thing we may ask ourselves are, why are there bare logs here? And the answer is, well, several years or decades before I took this picture, there was a fire here. This whole area used to be forested, and the fire burned down a lot of parts. And where we see the trees, like over here, that part didn't go up
get touched, right?
Yeah, it didn't go up in flames. So we see a whole lot of different interactions going on between trees, between the things that live in the forest, and between the whole environment. Like you may notice too that the types of trees you see here, it looks different than what we have there. You may not see its logos at a distance, but like look right here. Like what kind of tree does this look like? See, it's a cone shape.
Cone shape, right?
Like a Christmas tree.
Yeah, it looks like it.
Here our trees have like broad leaves mostly. So here are our definitions that you need to put down in your notes.
So you may want to pause it.
Right.
And write. So ecology is the study of the relationships between organisms and how they interact with their environment.
Okay.
So pause. Take notes.
And also the ecosystem, we'll see more about this later. The ecosystem is all the species that are in an area together with the environment that they're interacting with. So I guess we can move on because
Pause it.
We're now in the second part of the agenda. We're going to look at the flow of matter and energy.
A strategy that's never been filmed before. The brothers haven't eaten for 3.5 days. They're very hungry. An ostrich, a bird that towers over a cheetah, is more than twice as heavy and packs a powerful kick. Even with 3 cheetahs, an ostrich hunt is very risky. If one brother gets injured, the other 2 couldn't hope to bring down such large prey. On the other hand, if they succeed, they'll get the meal they desperately need. The male ostrich has spotted one of the brothers, but only one. He doesn't seem too worried. Then, suddenly, there are 3. The female has been slower to realize the danger, so the cheetahs switch targets. takes the combined effort and weight of all three brothers to bring down this powerful bird. Even now, the ostrich could land a fatal kick. But the cheetahs prevail.
So what do we see here with the cheetahs?
Well, we saw that the cheetah ate the ostrich.
Right. So it got its matter and its energy from the ostrich.
Right, but where did the ostrich get its matter and energy from?
Oh, didn't you see before that you saw the ostrich eating something like that, a plant or a seed?
Right.
So it got its matter and energy from there. Now where did that plant
And get the energy from now? Well, you learned, I'm sure, in biology or science in your early years, where does plant get their food from? Of course, from the sun through photosynthesis.
And here we have a similar picture. Where do organisms in their picture get their energy? So let's look at the picture and see we have three categories of organisms.
Right.
We first have the predators, and predator here.
Right there.
Here.
Looks like a
We've
lion.
got a lion. And then we've got the thing that the lion is chasing. Right here. It's a wildebeest, and that's classified as an herbivore.
Herbivore.
And what they eat, they're not seeing. Well, I guess
They're
right.
not seeing it. Well,
Here you
this
are.
one here looks like it.
We got the plants.
Right.
So, where do they get their energy? The lion gets their energy from the wildebeest.
By eating them.
Mm-hmm.
The wildebeest gets its energy from,
From the plants by eating them.
okay, and then the plants get energy from the sun by photosynthesis.
And we'll learn more about photosynthesis in another unit. Basically, what you see there is what you need to know about photosynthesis. Photosynthesis, the plants get all the matter and energy from what they need from the sun. Let's look at the population size.
So look at how many lines do you see there?
And how many wildebeest?
Just in this picture, because of course this is only a capture of, a small part of maybe the whole system. So how many wildebeest do you see there? Or you may want to stop to pause and you want to count, or just look at it quickly. Looks like there are probably like 1, 2, 3, 4, and there's one up here, 5.
I see 3 heads there.
Right.
So it's 6. And don't forget, I got one there and all the way back here.
All good,
I think
right.
that's a wildebeest too.
Right. So if you look at the comparison for the size of the population, what do you think about that?
Yeah, and we're forgetting another category too.
Drink some water here, I'm sorry.
Okay. And we got the plants. Lots and lots of plants, easy to forget. Now here's a vocab word that you need to put in your notes. A trophic level is a step in a food chain. Now the smallest trophic level here are predators.
The predators, right. The largest trophic level, the plants. You don't really, when you look at a picture, you probably don't notice, but if you look all the way around, this is all, plants, of course. Oh, I'm sorry, plants.
See it anyway, just look out the window. You see a lot more plants
Than us.
Why does this make sense? What if the situation was reversed? What if there was only one little bush out there?
And then many lines, many wildebeest, then?
Yeah, actually there are just as many lines out there as the grasses that you see here.
Oh boy.
What would happen?
Big trouble, because what would they feed on?
Yeah, they have one meal and that would be it.
They'll probably start eating each other, what do you think?
So basically, only 10% of the energy in one level moves on to the next level.
So what happens to the next 90%?
Good question. There it is.
Oh, there it is.
The organisms use it, and then energy cannot be destroyed, so it's lost as heat. Think about when you're in gym running laps.
Right.
You get hot and sweaty, so that energy which you used to run laps is then lost as heat.
Right. Which comes from some of the food that you eat.
Right. And so that food is not available to anything that will eat you, which hopefully won't happen
Won't happen
until you get to the decomposer after you're dead.
So here are some more definitions. You may want to pause, of course, take notes.
And there we have two sets of synonyms here. We have autotroph and producer, which are the same thing, and it's used interchangeably. You have to know both of them. And autotroph is a species and producer are species that make its own food. And so
An example, plants and by photosynthesis.
And heterotroph consumer, also the same thing. Both words will appear on tests, and the species that eat its food.
So make note of that.
Yeah. And we are heterotrophs, we are consumers. And here's
take a look at now this energy pyramid here.
It's a diagram where it puts everything in perspective for us, and energy pyramids appear in the tests. We've got the largest trophic level, the producers, at the bottom, and the smallest one up at the top. And you see it in various forms. Like you may see just the names of the animals in there. You may just see numbers.
Right.
And then you see the amount of approximate amount of energy, and you see that it goes down by tens each time. Kilocalorie is a unit of energy. Okay, now we come to Regents' questions. And these are just typical ones. These are not, we're giving the answers for these. These are not the questions that you're going to be writing down and handing in to us.
Right.
Okay, so the first one here, pyramid of biomass. Biomass is the amount of matter. And you've got the largest one at level 1 and the smallest one up at level 4. So which of those organisms would occupy level 4? Well,
would that be consumers?
Or producers.
Or producers.
Yeah. It would have to be a consumer, because down here at the bottom you've got the ones that make their food.
Oh, right.
Level 2 gets their energy from level 1, 3 from 2, 4 from 3. So one way to look at this is what's at the top, which one of these would not be eaten by any of the others?
Right.
And that would be the snake. So basically, like the snake, the mouse, which will eat the cricket, which will eat the plant. Now here we have two more. Here is one question, here's another one. And this first one here, we've got another biomass pyramid. And see which statement best explains why the total biomass of the snakes is less than all the other members. Oh, and I've got the answer already highlighted here. And it says that the correct answer is that there is a decrease in the available energy at each higher level. And that's what happens, because 90% is lost in each one.
And if you look back at the pyramid that we looked at before, it showed you that as well. That, 90% goes by like 1,000, 100, tens, and ones.
And looking at the other questions here, just to show you how they're incorrect. Number 2, the total energy of the producers is less than the total energy of the consumers. Well, if you look here, the green plants are the producers, and these are the consumers. Goes down by 90. The diagram here doesn't really show you all that well. It's not to scale.
Right.
But if the crickets here are 10% of the green plants, frogs are 10% of the crickets, snakes are 10% of that. So this is 100%, 10%, 10% of this. This goes down by another 10, so this would be 1% of that. That gives a total of 11%. And this would be 0.1%.
Right, because it goes down by 10.
So all of these consumers here, actually, when you add them all together, that would be 11.1%. Now the last one here, pyramid of energy, can also be used to illustrate the loss of usable energy at each feeding level in the food web, which feeding level would the smallest amount of energy be found.
Look at the answer. It's already highlighted for you.
Yeah. So why is it secondary?
Secondary, right.
Why is it secondary? Okay, well, if you look over here, the autotrophs and producers are the same thing. So actually, you could eliminate that altogether.
Right away.
Yeah.
And then you have the primary, even look at the pyramid up here,
Yeah. So autotrophs, producers, they go here in the bottom.
right?
Primary is the first one, and secondary goes on top.
And if you really look at it, it's asking for the smallest. So you have to look at the word. If it's asking largest, smallest, then, you know, that's how you try to figure it out as well.
Here, you see here is producers, primary consumers,
And
secondary
secondary
consumers,
consumers.
tertiary consumers. Concluding questions.
Oh, what is an autotroph?
And what is the source of energy in most ecosystems?
And define ecology.
And finally, why are there so many more plants than predators? And that concludes the podcast, and I look forward to seeing your answers for this tomorrow.
And questions.